I will be starting this assignment by running descriptive statistics to check the assumptions of normality and homogeneity of variance. Using the Chick Flick dataset, I'll be looking for separate descriptive statistics for each of the films, Bridget Jones' Diary and Memento. In order to do this, I'll be using the by function, which you can see on line 1 up here. I've specified that the data is going to be the arousal scores from the Chick Flick dataset, that it's going to be split. The results will be split based on the film category. The function that I'll be using to get the descriptive statistics is stat.desc, and I've set here that I want both the basic statistics as well as the normative statistics. So I'll go ahead and run that. And you can see that the output pops up down here. It shows both the skewness and the kurtosis values. The skewness value for Bridget Jones' Diary is negative 0.323, and then the kurtosis is negative 0.726. Basically what this means is that there's a slight negative skew of the data, which means that the data is slightly clustered along the right side of the graph with less data points to the left side. And the kurtosis means that there's a slight negative kurtosis, which means that it is a somewhat flattened data set rather than a rounded or a pointy data set. For Memento, you can also see the skewness and kurtosis scores. The skewness score is really close to 0, which means that in that respect it's very close to normal in the way it would look if the data set was normally distributed. Whereas the kurtosis is negative 1.259, which indicates that this is a very flattened data set. Next, I will be looking at the Shapiro test, which will test for significant deviation from normality. You can see that I've specified that the data that we want to look at is arousal in the Chick Flick dataset, and that we are once again splitting that up by film between Bridget Jones' Diary and Memento, and running the function of Shapiro test. So you can see down here that the Shapiro test for Bridget Jones' Diary came out with a non-significant p-value, as did the normality test for Memento. It was also not significant, which means that the data for both of these two films for arousal scores does not significantly differ from normality. Next will be the Levine test, which once again we're looking at the arousal scores, which will once again be broken down by film. You can see the output here that the p-value is also not significant. The Levine test tests for homogeneity of variance, which basically means that it tests whether or not the variance of different groups is equal. If it is significant, it means that the variances are different between the two groups, or in this case between the two films. But since this is not a significant result, it means that the variances between the data for the two films are not significantly different. So finally, with this data set, we will be building the histogram for the Bridget Jones Diary arousal data as well as the Memento arousal data. So the first thing we have to do is break the chick flick data set down into subsets so that we can graph each subset onto a histogram. So that's what I've done here in lines 7 and 8. You can see that it's going to be taking the data from chick flick and then breaking it apart by film. Specifically, the first film will be Bridget Jones' Diary. The second film will be Memento. I'll just go ahead and run those. And you can see that it created two new data sets over here for the Bridget Jones Diary data and the Memento data. So now that that's been created, each of those data sets can be plotted, which is what I've done here. The first one that I'll be doing is the Bridget Jones Diary plot. So once again, just like from last week, the first thing that you'll be doing is creating the object that specifies the plot using the ggplot function, which I've done here, and then adding the visual representation of the data plot, which in this case is a histogram here. And we'll be specifically looking at density, which is why y is set to equal density here. And then x will, of course, be the arousal score. And then I've just set some certain aesthetics here. The fill of the bars will be white. The color outlining the bars will be black. And the bin width will be 0.5. I've also added labels. In this case, there's a title, an X, and a Y axis label. And then this is the new part for this chapter's homework assignment. I'll be adding the normal curve as another layer. So this part of the function, or this part of the code specifies that we're trying to add a normal curve using function dnorm. And this normal curve is going to be based on the mean and standard deviation of our arousal data from Bridget Jones' Diary. And then I've specifically set the normal curve to appear at the color red, and the size of the line is 1. So I'm going to go ahead and run this. And then you can see what this looks like over here to the bottom right. You'll see the histogram, and then in red, the normal curve that was plotted as that second layer. So I'm going to do the exact same thing for Memento. I'm not going to run through the entire thing again because it's coded the exact same, just with Memento plot instead of Bridget plot. So I'm going to go ahead and run that. And you can see that graph here. So based on the graphs, the Levene's test scores, the Shapiro-Wilk test scores, and looking at the skewness and kurtosis, it does appear that the assumptions have been met for the two films, because the Shapiro-Wilk test did show that the data does not significantly deviate from normality for both films, and the Levene's test showed that the homogeneity of variance was met as well. So the assumptions for both of these sets of data are met. Now task 2. We'll be moving on to the R exam data. The first thing I'm going to do is create a histogram of the data. We're specifically looking at the numeracy scores for the R exam data. So once again, first thing I'll do is create the object that specifies the plot using the ggplot function. From the R exam data, we're looking specifically at numeracy, so I'm going to run that. Then I'm going to add the visual layers to this. In this case, it'll be a histogram, and then I'm also going to add some X and Y labels to this. and this is the histogram that comes up. From this histogram, you can see that the data is positively skewed. So because of this, I'll be choosing to use both a log transformation as well as a square root transformation to see if we can get this data to become normal. So the first transformation I'm going to do is the log transformation, which you can see right here, taking the log of the numeracy scores located in our exam. I'm going to run that. And then I'm also going to go ahead and just do the square root transformation. Now that that's done, I can create a histogram for both of those sets of data, which you can see here. Once again, the first step is always to create the object that specifies the plot. In this case, I'm going to be plotting log of the numeracy, and then adding the histogram layer on top of that, as well as the labels of both the x and y axis. And then I'm going to do the exact same thing for the square root. So here you can see the histogram of the log transform numeracy scores, and then the square root of the numeracy scores. So in looking at the graphs, it does appear that the data becomes a little bit more normal than the original graph, which I'll scroll through them so that it's kind of possible to see. Most of the scores are off to this side, and then this half, there's very few scores. If you look at both the log, you can see that it's somewhat more evenly distributed. And then here there's still some positive skew, but the data has become somewhat more normal. But in order to check this and make sure of this, I do want to run a Shapiro test on these, just to kind of add that in to my decision making on whether or not these data have become normal. So I'm going to run the Shapiro test of the original data, the log numeracy, and the square root. And you can see that the p-value for the original data is very, very significant, which means that this data does significantly differ from normality. And you can see that it's still significant for both of our log transform numeracy scores as well as the square root of the numeracy scores. So this data is not normal even after transformation. It does not become normal. So that is the end of the assignment for Chapter 5 and should answer all of the questions in that assignment.